Done with that water bottle? No problem. Go ahead and toss it in the recycling bin and hope it doesn't end up in the landfills. We as consumers can do everything in our power to shop at thrift stores and buy secondhand, to compost our food scraps at home, or even eliminate single-use plastics and try to live zero waste. But what about complex systems like phones, cars, and planes? There's very little that you and I can do in order to ensure that each material and each part is handled responsibly. This is up to government regulation and companies to ensure this. An alarming 10 to 11 million vehicles reach their end of life every single year. And while the average individual understands the complexities involved with developing and designing something like a car, most don't consider the difficulties, especially as it relates to recycling. To combat this, it's time we start understanding the challenges that these systems are imposing on us and design with green intention. But what is green intention? It's the idea of designing something with the intent to recycle it. Now, let's take a step back and draw some inspiration from nature. When an organism reaches its end of life, nature has a plan on how to recycle it. Decomposers can recycle dead animal and plant matter into carbon and nitrogen, which gets released into the soil, air, and water as nutrients for new plants and animals. This helps keep the flow of resources available in the environment. Similarly, we need to have a plan for when our products reach their end of life. Now, let's take a look at the life cycle of a product. First, raw materials are mined and harvested directly from the earth. They then go through some sort of processing or manufacturing, and then the product, be it a car, phone, plane, or electronic, the product hits the market. There are also social and marketing pressures associated with the life cycle of a product. Like, for example, you might have a phone that's totally functional, but decide to toss it because it's no longer fashionable or current. It's up to the user to determine how long the lifetime of the product will be. Another example is if you have a car and you use it for 20 years, and all of a sudden you want a new one or you totaled it, then this and this, these are car graveyards, and they're actually common throughout the entire world. Now, raise your hand if you want to be the person taking care of this mess. Yeah, me either. And to make it even more difficult, there are no instructions. There are a bunch of materials mixed into what looks like one part. The parts are hard to remove from one another, and there is a coating of paint all over the car, which is practically impossible to recover. To top it off, there are flaming batteries in there that will explode on you if mishandled. This is footage of someone making a tiny puncture in a phone's lithium-ion battery pouch. As you can see, it bursts into flames almost immediately and releases a toxic odor when the lithium from the battery reacts with moisture and oxygen in the air. In a matter of seconds, this tiny device that everybody has in their back pockets can do as much damage as a hand grenade. In an electric car, there are around 7,000 of these lithium-ion batteries. Now just try to imagine the damage that could occur if a recycler goes into work and accidentally mishandles a charged car battery. And multiply it again to look like this. It feels impossible, right? I have worked as a recycling innovation engineer at a tech company. I have hands-on experience dismantling, recycling, and disassembling electronics. I know what it is like to be in charge of a mess like this. From that experience, I can tell you that it's going to take time, maybe years for R&D to figure out how to recycle the device. And once they do, it will cost a lot of money to pay for the associated operating labor and to implement the disassembly device. And after all this time, money, and effort, it will pull more resources from our environment. It's like we're working backwards. It's a never-ending cycle if you begin to think about how to recycle the recycling device. It's time we start to challenge the status quo and design with green intention. We are the future of design, architecture, engineering, retail. There might be future policymakers or educators in this room who can and should build this notion into their curriculum. It is imperative that we change our thinking and our intention to understand these concepts for our planet's greater good. So before diving into the details of product design, let me tell you a bit more about recycling. First, at its core, recycling depends upon ease of disassembly. Think about it. The easier it is to take something apart, the faster it is to determine the materials within it and send it to its respective downstream recycler. Like, for example, metal will get sent to a smelter, whereas glass gets crushed, melted, and reformed. Currently, designers and recyclers don't work together. Once the product reaches its end of life, that's when the recycler has to figure out how to take care of it. This is why designers, recyclers, and engineers should collaborate from the start of product design. This is beneficial from both a sustainability and business perspective. That being said, they should work together to build disassembly instructions into a manual when the product is first released to avoid confusion when the time comes for it to be recycled. Next, source from recycled materials. Don't rely on taking from the earth every time that you need something. Adidas has been making these ocean plastic shoes. Think about it. Ocean plastic has negative value, and they are recovering it and selling it to you for over $100. Create a take-back system like Apple Trade-in. Apple pays their users a small fee in exchange for old devices so that they are the ones responsible for recovering and reusing the precious materials within the device. Discourage the production and consumption of single-use products and plastics like plastic bags, plastic water bottles, even paper towels. If these items take 450 years to decompose, why are they only being used once? It doesn't make any sense. Packaging as it relates to products and food is highly wasteful, and this is a problem that should have been taken care of yesterday. A more realistic use of single-use devices is within the medical field, where equipment needs to be sterilized prior to a procedure or surgery to avoid contamination, like syringes and pipettes and other medical devices. This is a good example of where innovation and proper waste management is necessary rather than halting production altogether. So these are a few ideas that scratch the surface of recycling. Let's look at more about what makes a product a good product. First, durability. Durability has to do with how it's made, the materials within it, and its structural integrity. Next is aesthetics. Aesthetics has to do with how it looks, how the impression is, the colors, the paints, and the overall feel. And finally, if it's an electronic, it must have a power source, like a battery, a charging cable, or fuel. So how can we implement green design and green intention into these three elements that make a good product? First, aesthetics. Avoid using contaminants. Use biosorts, paints, and glues where you can. Also, avoid using fasteners and screws. The less materials there are, the better. Don't compromise on the look of the product, but keep these ideas in mind while designing. Next, looking at durability, don't mix materials. For example, an everyday hanger could be made from wood and metal, or boxed water, which is made from paper and plastic. These items require an extra separation step when the time comes for recycling. Instead, just design with one material in mind, like a fully plastic or fully wooden hanger or fully aluminum can. On a larger scale, something like a car door will go through a shred and sortation. And once the pieces are shredded, all the materials will be thoroughly mixed together. And sortation is a lengthy sequential process that includes separations like vibration, density, magnetic, even stainless steel separation. And these often yield low purity results. It's better if we reduce the amount of materials that we have to begin with so that these output batches will be more pure and better for reusability. And finally, looking at power. Electronics contain precious metals like gold, silver, platinum, and even copper, and also rare earth magnets. It is imperative for economics that these are the easiest to remove, since they're the hardest ones to mine from the earth and the most expensive ones. Reusing and recovering these precious metals properly is a huge step in the right direction. And while precious metals occur in small quantities, they can really add up. All 5,000 of the 2020 Japan Summer Olympic medals were made from recovered precious metals from recycled electronics. That's 6.21 million phones diverted from the landfills and their precious metals all recovered. These ideas scratch the surface, but the future of our products and our planet is in our hands. And while these are great first steps for short-term and small-scale change, we need something that disrupts and disregards the status quo. For true exponential long-term change, fields like creative biomimicry or soft robotics, even creative reuse projects like those Japan Olympic medals and the Adidas plastic shoes, and of course, reducing the amount of flammable and toxic chemicals used in our power sources. Now, I mentioned earlier that nature has a plan for when an organism dies, and similarly, we need to have a plan for when our products reach their end of life. But what if we take that a step further and look at how nature creates in the first place? Everything in nature is grown, whereas everything that is man-made is assembled, part by part or brick by brick. Neri Oxman from the MIT Media Lab has taken this notion to the next level at the crossroads of environmental biology, art, architecture, and computational design. She has been creating structures made of one single material and one single part. She can control parameters of her structures like movement, mobility, structural integrity, and rigidity, all by simply manipulating its material properties. This is an image of Neri Oxman's silk dome. It covers 100 square feet and was grown, keyword grown, by 6,000 live silkworms. Compare this to a man-made dome, which is made up of a bunch of screws, fasteners, and hundreds of industrial metal rods. All of Oxman's creations are sourced from nature, and more importantly, they're designed for decay. Hear that? Designed for decay, meaning they return straight back to nature when the time comes for them to be recycled. Her research is the epitome of designing with green intention. Now, another noteworthy field is soft robotics. Soft robots mimic the way living organisms move and adapt to their environment. This is footage of a Harvard-designed octopus-inspired robot. It uses microfluidic movements to move, compared to a typical robot, which would use rigid mechanical movements. In the case of a robot's end effector, and an end effector is the claw or the hand at the end of a robotic arm, soft robots are made up of less materials, less fasteners, and less screws. And this is in line with the principles of designing with green intention, compared to a typical robotic claw or hand, which would be made up of several parts, screws, and fasteners. I want to make it clear that green design and green intention should not be seen as a burden or a chore that slows down progress, but rather something that facilitates it and allows advancements in a more sustainable way. Finally, looking at power. It is so important that we eliminate the use of toxic and flammable chemicals. Companies like Aminox have developed this lithium-ion battery that you could shoot a bullet through with no flaming reaction from the battery. This is already worlds better for the recycler, knowing that they can go into work without the worry of a battery exploding on them. At the crossroads of creative biomimicry, soft robotics, and safety power research lies the green design revolution. While this might be the greatest engineering challenge of our time, creativity and technology are moving in a direction where we can and should reverse the damage done to our planet. Let's make car graveyards and flaming batteries and single-use products a thing of the past. The bulk of environmental damage is done by large corporations, and it's unfair to assume that bringing a reusable bag to the grocery store is going to solve this problem, although it is a necessary step. It will take the union between businesses and creative engineers and decision makers to have the greatest impact. And while we do have some personal stakes in this, as I mentioned earlier, it requires a major disruption of the status quo. One day, you might be the next person designing the electric car or writing environmental policy. But until then, you can still affect positive change. You can choose to vote with your dollar and spend on products that were made with the end of life in mind. Learn how to dispose and recycle your electronics and batteries correctly, and more importantly, push your companies to give you clear instructions on how to do so. And finally, get educated on what you can do within your field. This is a problem that we should be taking on so that our planet doesn't have to. And with that, I hope you start living with green intention.